Hello, this is my submission for the testing component of the ECE 5000 design project. My project is the lamp that automatically adjusts its brightness based on the surrounding light level. Jumping right into it, the system currently is meeting the specifications outlined in the previous sections. The target brightness slider here controls the desired brightness. This is then sent to the Arduino, which controls the level of the brightness of the lamp. You can see we have two readouts here. We have the current brightness, which is hovering at the target brightness. We also have the value of the pulse width modulation signal being sent through the Arduino. This is excuse me, sorry. So as we can see here, the values change as we expect them to, as we change the target brightness. The system will adjust by lowering the pulse width value until the current brightness matches the target brightness. This is true for not just having the lamp on. Currently the room is dark. Were the room to be brighter, say if this overhead lamp was turned on, then the system would adjust such that the pulse width is lowered to keep the current brightness the same. So if we change the target brightness here to be 45, then with this overhead lamp on, we'll see that the pulse width modulation is at 23%. If we then keep the target brightness the same and dim the external light, the pulse width modulation is going to increase to keep the target's brightness at the same level. In previous instances of this project, there was an issue encountered at low values of target brightness, where the dimmest setting of the lamp would be too bright for the target, and the lamp turned off would be too dark. This has been circumvented now, so in situations like this, where the target brightness is very low, the system is going to start lowering the brightness. Once it gets to that point, it's going to recognize that its lowest brightness is going to be too bright, and it's just going to keep the lamp off. So you can see here, the current brightness is lower than the target brightness, and the pulse width is low at the point where the LED won't turn on. However, if the brightness is increased, the target brightness, the system will try again, and in this case, up at target brightness of 9%, the pulse width is possible to maintain that level of brightness. A similar instance happens when there's another external light. So currently I've turned on the bench lamp, and we'll decrease the brightness again here. And right now, I'm just going to get this into a specific range where the lamp is turned off in order for the current brightness to be obtained. Though if I were to artificially block the light sensor here, you can see that the lamp turns on to try and account for the artificial darkness that I've created. The lamp is thinking that it's darker than it actually is, and so it's compensating by trying to increase the brightness. When that's uncovered, you can see the lamp is turning back down to reach the point where the current brightness is maintained. You can see the lamp slowly turning off there as the pulse width goes to 0. Currently, the light sensor, the light-dependent resistor specifically, is just on a breadboard external to the lamp. The plan is to 3D print a small nubbin that'll fit in this hole that only has the end of the LDR poking out. Due to time constraints, that hasn't been done for this submission. There will be for the next one. So the end package will end up being just this lamp here with the small light-dependent resistor sticking out. In addition, the other piece of work left to do before the final project is complete is just clean up how the light is mounted in here and the excess wire in here. Those are small bits of work that'll be completed very quickly. Due to time constraints, I wasn't able to for the submission. Going through the code for the project here, I'm going to go through and give an explanation first of the Arduino code, and then I'll give an overview of how Node-RED is involved with this. So this first section here is just the initialization of the variables. That's largely unimportant. We have this here, which sets the baud rate for communicating with the computer. The main set of code here is this void loop. Breaking this down, we start with this, which gets the desired brightness from node red, as well as the light value read by the light-dependent resistor. Next is the main processing. This determines what the output of the Arduino should be based on its current state. So, down here, if it's currently brighter than what we want it to be at, it will decrease the value of the PWM. The PWM value corresponding directly to the brightness. So in the case where it's too bright, it's brighter than our target, it's going to lower the brightness of the lamp. In the case where it's too dark, it's going to increase the brightness. There is a clause here. This is the part that handles the case where the darkest that it can be while turned on is too bright and it turned off is too dark. So this here sets a flag that when looping through causes it to enter a waiting state where it just constantly checks to see if there's been either an update in the target brightness, which would indicate that it should try a different value, or it should try to get to that new value, or it'll also break out of this waiting statement if the light is covered up and the brightness experienced by the light-dependent resistor goes down. This indicates that the external light might be turned off and that the lamp now needs to turn on. Lastly, there are some lines here. So this is the line that actually controls the pulse width modulation on the Arduino directly. This line is what communicates to node red. So this sends out the data for both the light value being read by the light-dependent resistor, as well as the value being sent for the pulse width modulation. Lastly, there's a delay, so that way the lamp doesn't instantly change its brightness when a slight disturbance is caused over the light-dependent resistor. This is done just to avoid cases where like a piece of paper flicks over the light sensor and the lamp changes wildly. This is done to smooth out the output. Cutting over to node red here, we can see it's a fairly simple node red. We have the slider, which is this one here. The slider value is being both sent to this gauge here for a more graphical display, as well as to the Arduino via this brightness request node. This is caught here on the Arduino side by the serial read string line here on line 28. The next part of the node red code is where it reads out the values from the Arduino. So this node here is what reads out the message sent here at the bottom here, the combined informations. That is then sent to the split node, which will split the message into two different parts at the location of the ampersand in the Arduino code here. From there, the switch block sends it to the two different gauges so that they can be displayed. We have the brightness reader and the PWM reader, which are this and this. Getting to the project, the physical analog circuitry itself, that's all contained within the base here of this lamp. It all fits within. I'm going to be careful. I'm going to unplug it. Another note, the whole system is powered off of this 12-volt wall adapter. The cable connects into the back of the lamp here, as well as the USB cable, which connects to the computer, which allows for the automatic or the control of the targeted brightness for the automatic lamp. In the instance where the lamp isn't plugged into the computer, it will still operate, but with a predefined target brightness value of 45%, I do believe. So, getting into the internals of the lamp, I'm going to unplug it here out of safety. There is... there we go. We have the Arduino, which is that there, which has its power connected over to the PCB, and as well as its data lines for the outputting PWM signal and the inputting light sensor value. This board here, if I can untangle it there, contains all the components for the circuit. I'm going to be careful here to not poke anything too hard. So this contains the op-amp previously discussed, the BJT that's used for the pulse width modulation as well as a small Zener shunt circuit to regulate the voltage at 9 volts, which is the value used to power the Arduino. It's right in the middle of the operating range of 7 to 12 volts. The bottom here, this small plastic piece, fits within this little rim you can see here. This holds everything in place here. For the final product, that will be tacked in place with some hot glue so it doesn't open during use. But during prototyping here, I thought it would be better to leave it open like this so I can access it and show the internals of the circuit. That's everything about the project so far. As a brief overview, the project is the lamp with auto brightness. It's powered via this wall brick. It's connected to the computer through the USB cable. And in being connected to the computer, you're able to control the brightness, which is done by adjusting a pulse width modulation signal controlling an LED. And as for a recap on the work to be done, a small bit of 3D printing and some hot glue. That concludes the submission for this video. Thank you.